Hello and welcome back to the channel. In this video, we're going to be building a CRUD server using MongoDB and Express.js. The only prerequisite you need to follow along with this video is a basic knowledge of JavaScript. CRUD applications are the foundation for almost every interactive web application. CRUD stands for create, read, update, and delete. And that is what our server is going to do. It's going to allow users to create, read, update, and delete data that is stored in a database. For the database, we're going to be using MongoDB. Unlike traditional databases, which store data using tables, MongoDB uses object-like documents, which is going to fit well since we're going to be working with JavaScript objects. To set up our server, we're going to be using the Express package. Express is a package that is built on top of the built-in HTTP package or module, and by abstracting away some of the complexities of HTTP requests and responses, Express allows us to focus on the logic rather than boilerplate code. The server we're going to be building in this video is going to be for a task manager. It's going to include all the CRUD operations that we can perform on tasks like creating a task, reading all the tasks that are stored in our database, updating a single task, and deleting a single task. And in the upcoming videos, we're going to be building the front end, and we're going to connect it to the server that we're going to be building in this video. For this video, we're going to be using VS Code, but you can follow along with any editor of your choice. To create our server, we're going to follow 4 steps. The first is going to be project setup. This is where we're going to create our project folder and run the commands necessary to get started with our project. The second step is building the routes. This is where we define the different endpoints that the user has to go to access our server. The third step is setting up the database. This is where we're going to define what the structure of the data we want to store looks like, and we're going to connect to our database. And in the final step, we're going to put everything we built together, and we're going to refactor our code, and we're going to test out our server. Before we start writing code, we need to install Node. Node is an environment that allows us to run JavaScript outside of our browser. To download Node, we're going to head to the following link, and based on our operating system, we're going to choose a download option. Once we've installed Node, we're going to head back to VS Code, and we're going to create a new terminal. And to verify that we've installed Node successfully, we can run the command node-v. And if we get a version of Node, and if we don't get an error, that means we've successfully installed Node. The next step is going to be navigating to where we want our project to be stored. And once we're at that location, we're going to create a new folder using the command mkdir. And we're going to give our folder a name. In our case, we're going to give it server. And we're going to move into that folder using the cd command. Once we're inside our server folder, we're going to run the command npm init. This is going to initialize our Node project. In the initialization process, we're going to be asked to enter a package name. We can use the default by pressing enter. For the version, we're going to use the default. Again, we're going to press enter. For the description, we can leave it empty. And for the entry point, the default is going to be index.js. We need to keep note of this file name because we're going to create it later on. And for the test command, we're going to leave it empty. Git repository, we're going to leave it empty. Keywords, we're going to leave it empty. And for the author, you can put in your name or you can leave it empty. And finally, once we've chosen a license, our Node project is going to be initialized. It's going to ask us to verify the details we've entered so far, and we're going to press enter. Now, if we look at our file structure, we can see that inside the server folder, there's a new file that has been created called package.json. And we can open up this file. So this file is going to store different informations about our project. Some of the key concepts we're going to be looking at in this file is the scripts key. This is where we define shortcuts for different commands. And once we start installing external packages, we're also going to have a dependencies key, which is going to store all the dependencies of our project. Back in the terminal, we're going to install the external packages that we're going to use. And the command to install a package is npm install. And we can give it a series of external packages that we want to install. In our project, we're going to use Express, Mongoose, .env, and course. We're going to look at each package in more depth, but to give you an overview, we're going to be using the Express package to set up our server. We're going to be using Mongoose to connect to our database and to communicate with our database. We're going to use .env to store private information. And we're going to use the cores package to allow our server to be accessed from different IPs. Once we've entered our command, we can press enter. Now the installation might take some time. Once the installation is done, if we go back to our package.json file, we can see that a new key has been added, which is dependencies. And this is going to store all our external dependencies together with their version. Back in our terminal, there's one more package we need to install, which is the nodemon package. We're going to use the nodemon package to restart our server automatically whenever we make changes to our code. But the installation is going to be a bit different since we're only going to be using this external package during development. So to install dependencies that we're only going to use when we're developing our server, we're going to use the same command. So we're going to have npm install, then the name of the package, which is nodemon. But we add an additional option, which is --save-dev. So this is going to install nodemon as a development dependency. So if we go back to our package.json, we can see that we have a new key, which is dev dependencies, and we have nodemon together with its version. As we previously said, we can set up shortcuts in the script key. So inside the scripts key, we're going to add another key value pair, and we're going to call it dev. And what this shortcut is going to do is it's going to run our server using nodemon. And to do that, we're going to have nodemon followed by our entry point. If you remember when we were setting up the project, we set our entry point to be index.js. So now by running the command npm run dev, we can run our server using nodemon. The final step in our project setup is going to be creating our entry point. So in our server folder, we're going to create a new file and we're going to call it index.js. We're going to be using the Express package to create our server. So the first thing we need to do is import it. To import an external package in a Node project, we're going to use the require function. So we're going to have require. And in parentheses, we're going to pass in the name of the package that we want to import, which in our case is going to be Express. Now to access the different functionalities inside the Express package, we're going to store our import statement in a variable, and we're going to call it Express. And we're going to initialize our application. We're going to create a variable called app, and we're going to set it equal to Express. The next step is going to be setting up our routes. Routes are going to be addresses that the user goes to in order to communicate with our server. When the user interacts with our server, there are different actions the user can perform. These actions include get, when the user wants to get data from our server, post, when they want to create something on our server, patch, when they want to update data on our server, and delete, when they want to delete data from our server. The first action we're going to be looking at is the get action. So to handle the functionality when the user sends a get request, we're going to use app.get. The get function is going to take in two arguments. The first is going to be a path, and the second is going to be a callback function that is going to execute whenever the user goes to that path. So if we define a path as /hello, then our callback function is going to execute whenever the user goes to /hello in our server. For now, we're going to leave this as a / alone. This is going to refer to the root of our server. And the callback function is going to take in two special objects as parameters, which is going to be request and response, which by convention we usually call rec and res. The request object is going to contain all the information related to the request that is sent to our server. And the response object is going to contain different functions that we can use to send or respond back to our user. So in this case, since we want to respond to the user, we're going to use the res object, and we're going to access the send function, and we're going to pass in hello world. Finally, to continuously run our server, we need to be listening to a port, and to listen to a specific port number, we're going to use app.listen, which is going to take in two arguments. The first is going to be the port number, and the second is going to be a callback function, which is going to execute if our server has successfully started. So for the port number, we're going to pass in 3000, and the callback function is simply going to log server started. Now we can save our file, and in the terminal, we're going to run our server. If you remember, we set up a shortcut to use nodemon. So in order to run our server using nodemon, we're going to use the command npm run dev. Once we see that server started has been displayed in our terminal, that means our server has successfully started. Next, we're going to open up our browser. In our browser, we're going to head to the link http://localhost, and after another colon, we're going to put in the port number we used, which in our case was 3000, and the path we were handling was a /, which is the root of our server. And now if we press enter, we get hello world back from our server. Now using the same concept, we can set up different routes. So we can have another app.get, and for the path, we're going to give it /home, and we're going to have our callback function, which is going to respond with homepage. Let's add another route for an about page. So we're going to have app.get. The path is going to be /about, and inside the callback, we're going to respond with about page. Once we've set up our routes, we can save our file and head to the browser. So again, the root of our project is going to return hello world. And now if we go to /home, we're going to get the home page. And if we go to /about, we're going to get the about page. Now that we know how to set up routes, let's set up the routes we're going to use for the actual project. So we're going to need 5 different routes. The first is going to be a get route, and this route is going to be responsible for returning all the tasks that are stored in our database. So we're going to have app.get. For the path, we can give it any path we want, but by convention, we usually give it the path /API, / the version of our API, which in our case is going to be v1, and another /, and we're going to have the name of the data we're going to be returning, which in our case is going to be tasks. Now this is a convention. You can define your paths however you want. And next we're going to have our callback function, which we're going to leave empty for now. The second route we're going to define is the route that is responsible for creating a new task. And to create a new task, we need to use the post method. And for the path, we're going to pass in /API /v1 /tasks. Again, this is a convention. You can use another path if you want. And again, we're going to leave the callback function empty. The third route is going to be a get request, but this time it's going to return only a single task based on the ID we give it. Here we need to look at a concept called route parameters. Route parameters are similar to parameters in JavaScript, but the main difference is that we pass them directly in our path. So in our case, we're going to have app.get, and the path is going to be /API /v1 /tasks / the ID of the task we want to get. Now to define a route parameter, we need to use a colon followed by a variable name, which in our case, we're going to call it ID. Now we can extract this ID and use it in our callback function. To see this, we're going to define our callback function. And inside, we're going to have a variable called ID. And in this variable, we're going to store request, so the request object, which contains all the information of the request being sent by the user. And inside this object, we're going to access the params, so this stands for parameters. And again, we're going to have another dot, and we're going to put in the variable name, which in our case is ID. To see this, we're going to send a response with the ID, and we're going to save our file and head to the browser. So in the browser, if we go to /API/v1/tasks/an ID, let's say we give it 1234, and if we press enter, we get the ID returned. So later on, we're going to use this ID to manipulate our database. The fourth route is going to be a patch route. This route is going to be responsible for updating the information of a single task. Again, since we're dealing with a single task, we need to use the ID route parameter. So we're going to have app.patch. For the path, we're going to have /API/v1/tasks/ID. And for now, we're going to leave the callback function empty. The final route we need to set up is the delete route, which is going to be responsible for deleting a single task. Again, we're dealing with a single task, so we need to use route parameters. So we're going to have app.delete, and we're going to pass in /API/v1/tasks/ID, and we're going to leave the callback function empty. Now that we have all our routes set up, we need to create our database. To create a database, we're going to be using MongoDB Atlas. So we're going to head to our browser. In our browser, we're going to search for MongoDB Atlas, and we're going to open the first link. If you have not created an account yet, you can press on Get Started and create a new account. In my case, I already have an account, so I'm going to sign in. Once you've created an account, you're going to be prompted to create a new cluster. When creating a new cluster, you can use all the default options. The only thing you need to change is making sure that you're using the free version. And once your cluster has been created, there are two more settings we need to access. The first is going to be database access. In here, we're going to set up a username and a password. So to show you, I'm going to delete the existing user. And we're going to create a new database user. So you can give it your own username and password. So I'm going to give it Abel. And for the password, I'm going to give it 1234. In your case, you can use a more secure password. I'm using a simple password for demonstration since I'm going to be deleting this user. And once you've set up your username and password, you can scroll down and add in a built-in role. And we're going to select the role that allows the user to read and write to any database. And we're going to click Add User. The next option we need to modify is the network access. So in here is where you're going to define the different IPs that can access your database. In our case, we want our database to be accessed from anywhere. So we're going to add a new IP. And we're going to click on the option that says Allow Access from Anywhere. And we're going to click on Confirm. Once our status says active, we can move on to the next step. The next step is going to be getting our connection string. So we're going to head back to clusters. And in our cluster, we're going to click on Connect. And we're going to choose drivers. And for the driver, since we're going to be using Mongoose, you can click on the drop down and choose Mongoose. And by scrolling down, we can find our connection string. So this is going to be our connection string. We're going to copy this and paste it in our project. Once we have our connection string, since it contains our password and we don't want to use it directly in our application, instead we're going to store it as an environment variable. So in the root of our project, we're going to create a new file and we're going to call it .env. And in this file, we can store different key value pairs. So in our case, we're going to have Mongo URI as the key. And for the value, we're going to paste in our connection string. In the space where it says db_password, we're going to put in our password. In this case, we set it to 1234. One more thing we can modify in the connection string is going to be the name of our database. To define the name of our database, we're going to go to the slash and question mark. And in between, we're going to give our database a name. In our case, we're going to call it Task Manager Tutorial. You can give it any name you want. Another variable we usually find in .env files is the port variable, which is going to store our port number. In our case, the port number we are using is 3000. And once we've defined our key value pairs, we can save this file and head back to our index.js file. Now, to use the different environment variables, we need to import the .env package. So at the top of our file, we're going to require .env. Since we're only going to be calling one function, we don't need to store it in a variable. We can directly call .config, which is going to set up our .env package. Now let's see how we can use the environment variables. So we're going to head to our port number, and instead of directly passing 3000, we're going to pass in process.env followed by a dot, and we're going to put in the variable name, which in our case is port, and we can save our file. Now, if you're pushing this project to GitHub, you need to make sure that in your gitignore file, you include .env. Since it stores sensitive information, we do not want to push it to GitHub. Next, we're going to import the Mongoose package, which is going to allow us to interact with our database from our code. Now, by convention, our database connection code is going to be stored in a different file. So in our server folder, we're going to create a new file, and we're going to call it connect.js. And inside this file, we're going to import Mongoose. And since we need the connection string to connect to our database, we're also going to import the .env package. And we're going to call the config function. So we can access the environment variables inside this file. To connect to our database, we're going to use the connect function. So we're going to have mongoose.connect, and we're going to pass in our connection string, which in our case is stored inside process.env.mongo_URI. Now this function is going to return a promise. A promise in JavaScript is an operation that is either going to succeed or fail. And to control what happens when it succeeds, we use the .then function. And to handle what happens when the promise fails, we use the .catch function. So in our case, if the promise is successful, that means we've connected to our database. In that case, we're going to console.log database connected. And if the promise fails, that means our connection to the database was not successful. In that case, we're simply going to log the error. Now, since the index.js file is the entry point of our application, and we need to connect to the database before we start our server, we need to export this function to our index.js file. And to do so, we're going to wrap it in another function, and we're going to call this function connectDB. And this function is going to take in a URL as input, and it's going to call the mongoose.connect function. Now, instead of passing in our environment variable directly, we're going to pass in the parameter URL. In order to use this function in our index.js file, we need to first export it. And to export a component in a Node project, we can use module.exports, which is an object. And this object is going to contain all the components that we want to export. So if we had multiple components, we would put them in an object. But in our case, we only want to export the connectDB function so we can directly pass it in. And once that's done, we can remove the import for the .env package since we're not using it anymore inside this file. So we're going to remove it, save our file, and head to index.js. Inside index.js, we're going to import the connectDB function. So we're going to have const connectDB. Again, if we were importing multiple components, instead of passing in one name, we would have an object of the different components we wanted to import. But in our case, we simply want to import connectDB, and we're going to set it equal to require, and we're going to pass in the path for our connect.js file. When importing a JavaScript file, adding the extension is not required, so we can leave it as just connect instead of connect.js. So connecting to the database might fail for different reasons, like connection issues or an invalid connection string. So what we want to do is first try to connect to the database, and if and only if that succeeds, we want to start up our server. So to achieve this, we're going to create a new function, and we're going to call it start. And inside the start function, we're going to first call the connectDB function. So we're going to have connectDB. It's going to require the connection string, which we can access using process.env.mongoURI. So we want the connectDB function to return a promise. And based on the resolution of that promise, we're going to start our server. So if we want connectDB to return a promise, we need to go back to connect.js and add the return keyword to mongoose.connect. And now we can go back to our index.js file. And another way of handling promises in JavaScript is using async await together with a try-catch block. So how async await works is we're going to wait for the promise to be resolved. And if the promise is successful, we run the code in the try block. And if an error occurs, we go to the catch block. So to define this function as async, we're going to have the async keyword. And for the connectDB function, we want to await the results of the promise. And next, we need to add our try catch block. So we're going to have try. And inside the try block, we're going to have our await. If the promise is successful and we've connected to our database, we want to start up our server. So we're going to move app.listen inside the try block. And next, we're going to define our catch block, which is going to catch any errors. And we're simply going to log the error. And the final step is going to be calling this function. So we're going to call start. And now if we save our file and look at the terminal, we can see that first, database connected is displayed. This means before the server starts, we connect to our database. And if that is successful, then our server gets launched. Our next step is going to be defining the structure of a task in our application. And this structure is known as a schema. And by convention, we place our schemas inside a folder called models. So inside our server folder, we're going to create a new folder called models. And inside this folder, we're going to create a new file called task.js. To create a model, we need the Mongoose package. So we're going to first import it. We're going to create a variable called task schema. And we're going to use the mongoose.schema function. To create an instance of a schema, we're going to use the new keyword followed by mongoose.schema. Now this function is going to take in an object as a parameter. And inside this object, we're going to define different key value pairs. The key is going to represent a property of a task. For example, a task can have a name, it could have a completed status, and the value is going to be the data type of that property. So if we wanted to define a simple key value pair, we can simply have name and the type is going to be string. We can also have completed and the type would be Boolean. So this is going to create a schema with two properties, name and completed. Now, if we want to apply more constraints and validations to each property, instead of directly passing in the data type, we can pass in an object. Now using type, we can define the data type, which in our case is string, but we can also add other validations. For example, we want the name property to be required. To do that, we're going to set required to true. And for the completed property, we're going to set an object. Again, the type is going to be Boolean. And for this one, we want to set the default value to false, which makes sense since when we create a new task, it's not going to be completed. And to define a default value, we're going to use default, and we're going to set it to false. Once we finish defining our schema, we need to export a model that uses the schema. So we're going to have module.exports, and we're going to use mongoose.model, which takes in 2 arguments. The first is a name that represents a single object in our database. In our case, it's going to be task. So task represents a single object. And the second argument is going to be the name of our schema, which in our case is task schema. So what mongoose.model is going to do is it's going to take our first argument, which in our case is task. It's going to convert it to lowercase. So we're going to have task with a lowercase, and it's going to make it plural. So we're going to have tasks, and it's going to use this name as the name of our collection. So a collection in MongoDB is similar to a table in a traditional database. So our collection name is going to be tasks. So we're going to save our file and go back to our index.js file. And in order to use the model, we need to import it. So at the top of our file, we're going to have const task, and we're going to require the path of our model, which is in ./models/task. Before we start implementing our routes, there's an extension in VS Code that we're going to be using to test out each route, and that is the Postman extension. To install this extension, you can simply go to the extensions tab, and you can search for Postman. And you're going to install this extension. Once the extension is installed, you should see the Postman logo on the left side. The first route we're going to be working on is going to get all our tasks. So inside our callback function, we're going to create a variable called tasks. And we're going to use our model. So we're going to have task dot, which is going to give us different functions we can use to manipulate our database. In our case, we're going to use the find function. So we're going to have find, and the find function is going to take in an object as input. And inside this object, we can define a property, and based on that property, it's going to return all the matching objects. So if we had completed set to true, this is going to find all the tasks that have completed true, and it's going to return it to us. But in our case, we want to get all the tasks, so we're going to leave this object empty. The functions we're going to be using are going to return a promise, so we're going to convert our callback to an async function, and we're going to await for the result. And when we have async and await, it's always a good idea to include a try-catch block. So we're going to have our try-catch block, and inside the try, we're going to have our find function. And once we have all the tasks, we're going to send a response. So we're going to have res dot. We're going to be sending our response in JSON format, and in order to send back a JSON, we can use .json, and we're going to return an object which has a key tasks, and the value of that key is going to be the tasks we get back from our database. Now, when we have key value pairs that have the same name, we can actually use a shorthand. So we can remove one of the tasks and we can simply pass in tasks. When responding to a request, we can have different outcomes, and to represent these different outcomes, we use status codes. Now, you don't need to memorize any status codes, but in our case, we're simply going to add one. So we can chain it. So we're going to have .status, and in parentheses, we're going to pass in our status code. In our case, we're simply going to pass in 200, which means successful, and we're going to chain .json. Next, we're going to define our catch block, which is going to catch any errors, and it's simply going to log the error. Now, since we have no tasks stored in our database, we can't test this route just yet. But once we define our post route, we're going to test them together. So next, we're going to work on the route that is used to create a new task. Since we're going to be dealing with promises here as well, we're going to define the callback as async, and we're going to have our try catch block. And to create an object, we're going to use the create method. So we're going to have a variable called task, and we're going to call task.create. The create function takes in an object, and it's going to send that object to our database. In our case, we're going to let the user send the object, and we can access the object that the user sends using the request object, and we're going to access the body property. So request.body is going to be an object that the user sends to our server. But there's one more thing we need to configure here. By default, when a user sends an object with their request, it's not added to request.body. In order for the user's object to be added to our request.body, we need to use something called a middleware. In simple terms, a middleware is a function that gets executed in between a request and a response. So in our case, the middleware is going to get in between the request, and it's going to add the object that the user sends to request.body. Now, since we're using Express, and Express has a built-in middleware that handles this operation, we're going to go to the top of our file, and to use a middleware, we're going to use app.use. Now, this is going to take in two arguments. The first is going to be for what paths we want to apply this middleware to. So for example, if we had /home here, and if we put in our middleware, this middleware is only going to be applied to the routes that start with /home. But in our case, we want this middleware to be applied to all routes, and in order to do that, we're going to remove the first argument. So the middleware we want to use is express.json. One thing you need to remember here is that the placement of app.use matters. If we were to place app.use at the end of our routes, that is not going to work. We need to place it before the routes that are going to use the middleware. So now we can go back to our create a new task route. And since request.body has access to the object that the user sends, we can pass it to create. And when we pass in this object, it's going to be checked with the different validators that we defined in our model. So we defined that the name is required and the completed property is going to be false by default. So if the user sends an object with no name property, we're going to get an error. Once we've created the task, we're going to respond with the new task that has been created. So we're going to have res. The status code for a new resource being created is 201. And we're going to chain.json, and we're going to pass in our task. Now, if there is an error, we're going to define our catch block. Now, instead of simply logging the error, what we can do is respond with a different status code. So we're going to have status 500, which deals with server errors, and we're going to respond with a JSON, and the object is going to be MSG, and we're going to pass in the error. Now we can use the same catch for all our routes. So we're going to copy this and paste it in our previous route. Now that we've defined the routes for getting all our tasks and creating a new task, we can test them out. And to test these routes, we're going to use the Postman extension. So first, let's save our file, and we're going to open the Postman extension, and we're going to click on New HTTP Request, which is going to open up a new tab. And here we can pick what action we want to perform. So the first one we're going to test is creating a new task. So we're going to choose post, and we're going to pass in our route, which is HTTP localhost. Our port number is 3000, and our path is /API/v1/tasks. Now we want to send an object with this request, and to do that, we're going to head to body, and we're going to pick raw, and for the type, we're going to pick JSON, and we're going to pass in a new task. Our task model included a name and a completed property, so we're going to have name. Don't forget to place your key and value pairs in quotation marks since we're using JSON. And for the name, we're going to give it testing1. And for the completed property, we're going to give it true. And now we can send our request. using the send button. And if we look at the response, in the response, we're getting an empty object. This should not be happening. So we're going to go back to our index.js file. And the problem is we're not awaiting for the promise. So we forgot the await keyword. So when we create the task, we're going to use await. So now we're going to wait till the new task is created. Then we're going to respond. So we can save our file and go back to Postman. And we're going to create another task. For the name, we're going to have testing2. And we're going to set completed to false. And we're going to send our request. Now, if we look at the response, we can see the new task that has been created. Now, there are some properties that we have not defined, like _ID. _ID is generated by MongoDB automatically for all our objects. So we're going to be using this ID to identify an individual task. So let's create some more tasks. So we're going to have another one with testing3. And we're going to leave out completed. We can do this since we defined a default value for the completed property, which was false. So if we send our request and look at the response, we can see that a new task has been created and the completed property is set to false. And one more time, we can test that the name property is required. So for example, if we set name to an empty string and try to send our request, we can see that we get an error. Now that we've created a couple of tasks, we can test the route for getting all our tasks. So we're going to change the request from post to get, and we're going to send our request. And if we look at the response, we get an array of all the tasks we've created so far. Now, to verify that each task has been added to our database, we can go back to MongoDB Atlas. And in our cluster, we're going to click on Browse Collections. And the name we gave our database was Task Manager's Tutorial. So we're going to open that. And again, the collection name is going to be tasks, which is similar to a table in a traditional database. So we're going to open the collection. And as you can see, the different tasks we created have been added to our database. The next route we're going to implement is the route responsible for getting an individual task. So here we're going to have get single task. And previously we already extracted the ID from our path, so we're going to use it again. And we're also going to be dealing with promises, so we're going to have async. And we're going to create a try-catch block. So first we're going to extract our ID from our path, and we're going to create a new variable called task, and we're going to use the function task.findOne. So the findOne function is going to take in an object as input, and based on the property we give it, it's going to find the specific task. So in our case, we're going to be using the ID, and as we saw previously, MongoDB generates an ID for each object. So the name of that property was _ID, and we want to check if that ID matches the ID we have in our path. Again, we're going to get a promise, so we're going to await. And once we await, there are two things that can happen. Either we find the task, or the ID does not exist, and our task is going to be undefined. So in order to check this, we're going to have an if statement. And if task is undefined, we can check that using !task. If that is the case, we're going to respond with a status code of 404, which stands for not found. And we're going to return a JSON that says task not found. Now here we need to make sure that we return the statement, since we don't want to run the remaining lines of code if the task is not found. And outside our if statement, if the task is found, we're going to respond with a status of 200. And we're going to return a JSON of that task. And we're going to define our catch block, which is going to respond with a status of 500. And we're going to have .json, and we're going to return our error. Now here, you might be wondering why we have two checks for errors. So the first is going to be the catch block, And the second is if the task does not exist. So this is going to run if the ID we provide is the correct format, but that ID does not exist. But the catch block is going to run if the ID has an invalid format. We're going to see how this looks when we test this route in Postman. So we can save this file and go to Postman. First, we're going to get all our tasks to extract an ID. So we're going to take testing2. So we're going to copy the ID of testing2. And what we're going to do is pass in that ID to our path. And now when we send a GET request, we get testing2. Now, if we pass in an ID without the correct format, let's say we remove this and pass in A, B, C, D. In this case, the catch block is going to run. So if we send a request, we get a long message of the error that occurred, but we don't see task not found. Now, if we send an ID with the correct format, but if that ID does not exist in our database, for example, we can remove 5 and replace it with 6. And now if we send this request, we get our task not found message. So now we verified that getting a single task from our database works. So we're going to head back to our index.js file. The next route we're going to work on is the route that is responsible for updating a single task. Again, we're going to have async. Now this is going to be similar to getting an individual task. So what we can do is copy the code we have here, and we're going to paste it and modify some things. So when we want to update a task, again, we're going to extract the ID from our path. And instead of calling find1, we're going to call find1 and update. Now this function not only takes in an object to find the specific task, but it also takes in a second object, which contains properties that we want to update. So if the user, let's say, sends an object with the name property and gives it a new name, this function is going to find the task with that ID, and it's going to update the name property. In our case, we want to access request.body, since the user is going to be sending the object inside their request. Again, we're able to access request.body since we set up the Express.json middleware. The task not found code is not going to change. If task is undefined, we're going to respond with task not found. And if the update is successful, we're going to respond with the updated task. Now here, we're going to run into one issue. So to see this issue, we're going to save our file and head to Postman. So first, we're going to get all our tasks. And we're going to be updating testing1. So we're going to copy the ID. And we're going to pass it to our path. And instead of get, we're going to have patch. And we need to pass in an object of properties that we want to update. So the name was testing1. And we're going to replace it with hello world. So now if we send this request, and if we open our response, we see that the task has been returned and our status is 200 OK, which means it was successful. However, the task we're seeing here is not the updated task. As you can see, the name still says testing1. This is one of the issues we have. The other issue we have is, let's say we set the name to an empty string. Now this should not work since in our model we defined that the name is required. But if we send this request, and if we look at the response, again we get the outdated task, but to see the updated task, we're going to call the route that's going to get us all our tasks. So we're going to use get, and if we send this request, in our response, we can see that the first task has a name of an empty string, which is not allowed. Now to fix these two issues, we're going to head back to our code. And inside the find1 and update function, we're going to add a third object, which is going to allow us to run different options. So the options we want to run are setting the new property to true. This is going to make sure that the returned task we get is the updated one. And the other property we want to add is run validator. And we're going to also set it to true. So this is going to make sure that when updating a property, we first check that it matches the validation that we defined in our model. So we can save this file and head back to Postman. So first, let's see that the updated task is getting returned. So we're going to get the ID for testing 2. And we're going to add it to our path. And we're going to send a patch request. And we're going to update the name to hello world. Now if we send this request and see our response, we can see that now we have the updated name. Now the second issue was the validator. So let's say we set this to an empty string and send our request. If we look at our response, we are still updating our name property to an empty string, which is an error. So we're going to go back to our index.js file. And our problem is that the property name is actually run validators instead of run validator. So we're going to save our file and head back to Postman. And we're going to get all our tasks using the get method. And we're going to go to testing 3. We're going to get the ID. And we're going to put it in our path. And we're going to send a patch request with an empty name. And now if we send this request, as you can see, we get an error. So that is going to be it for our update path. So we're going to head back to our index.js file. And the final path we're going to define is the delete a task path. Again, this is going to be very similar to the other paths we've defined. So we're going to copy and paste the one we have here. One thing we shouldn't forget is adding the async keyword. So here we're going to extract the ID, and instead of find1, we're going to call find1 and delete. So it's going to find the task with the ID we provide. If that task does not exist, it's going to return task not found. But if that task has been deleted, again, when we delete a task, we usually do not respond with the task, so we can remove this JSON. And instead of .json, we're simply going to send back task has been deleted. And we're going to save this file and head to Postman to test this route. First, we're going to get all our tasks. And let's say we wanted to delete this one, the one without a name. So we're going to copy its ID and add it to our path. And we're going to change get to delete, and we're going to send this request. As you can see, we get task has been deleted. Now to verify this, we can get all our tasks again using the get method. And as you can see, the task with no name has been deleted. And we verified that the delete route works. So what this means is that our server successfully supports all the CRUD operations. Now we're going to apply some small tweaks and refactoring. Back in our index.js file, we're going to import another package called course. We're not going to be using this package for this video, but in the upcoming videos, when we build a front end and we want to access our server, this package is going to make our server accessible from different IPs. So for now, we're going to set it up. Since it's a middleware, we're going to use app.use, and we're simply going to pass in course. And we can save our file. Now the coming tweaks we're going to apply are completely optional. So we're going to be refactoring our code. If you look at our index.js file, it has gotten pretty long. So we're going to break up our code into different files. The first step we're going to do is refactoring our routes. Now by convention, all our routes are going to be stored in a folder called routes. So what we're going to do is cut out all the logic related to our routes. And in our file structure, we're going to create a new folder. We're going to call it routes. And inside this folder, we're going to create a new file called tasks.js. So in here, we're going to paste in our route logic. You may have noticed that we do not have access to the app variable from this file. So we're going to be using something called a router. So we're going to first import Express. So we're going to have const Express, and we're going to require Express. And we're going to create a router. To create a router, we're going to use express.router. Now using this router, we can set up our different routes. So instead of app, we're going to have router. And once we've updated our code, what we can do is export this router and use it in our index.js file. So we can have module.export, and we're going to set it equal to router. And one more thing we need to import is here we're using the task model. So we're going to head back to our index.js, and we're going to cut out the model import, and we're going to move it to our new file. Another tweak we can apply is if we look at our paths, most of them look similar. So they all start with /API, /v1, /tasks. So what we can do is instead of having this path, we can simply have a slash, and we're going to define the /API, /v1, /tasks when we import our router in the index.js file. So we're going to update all our paths. For the post, again, we're going to have a slash. For the get a single task, we're going to have /ID. For the update a single task, again, we're going to have /ID. And finally, for the delete task, we're also going to have /ID. And we're going to save our file. And back in our index.js file, what we're going to do is first import our router. To do that, we're going to have const router. And we're going to require ./routes/tasks. So to use this router, we're going to have app.use, and we're going to pass in our router. But if you remember, the use function takes in two arguments. The first is the path that we want to apply the middleware to. So in our case, the path we're going to pass is /API, /v1, /tasks. So this path is going to be common to all our routes. We're getting an error that says cannot find module./models/task. And the problem is in our routes file, we need to update the path since it's not in the same level as our index.js file. So we're going to have .. Then we're going to have models. Then we're going to have task. And now we can save our file. The second refactoring we're going to do is moving the callback functions into their own file. By convention, we're going to move it into a folder called controllers. So we're going to create a new folder. And we're going to call it controllers. And we're going to create a new file called tasks.js. And in this file, we're going to have our callback functions. So we're going to go back to our routes, and we're going to cut the first callback function. And we're going to define a function called getTasks in our controller. And we're going to paste in the function we copied. Again, here we're using the task model. So instead of importing it in routes, we're going to take it to our controllers file. So that is get tasks. Next, we're going to get the callback for the post request. And we're going to create a function called create task. And we're going to paste in our function. Next, we're going to get the single task callback function. And we're going to create a function called get task, and we're going to paste in our callback. Then we're going to copy the callback for the update function. And we're going to create a new function called update task. And finally, we're going to copy the callback for the delete function. And we're going to create a new function called delete task and paste in our callback. Now we've defined all our controllers. The next thing we need to do is export these functions. So we're going to have module.exports. Now, since we're going to be exporting multiple components, we're going to pass in an object and we're going to pass in the name of each function. So we're going to have get tasks, get task, update task, create task, and delete task. And we're going to save our file. Next, we're going to head to our routes and we're going to import these functions. So we're going to have const. Again, we're importing multiple components, so we're going to have an object and we're going to pass in the name of our functions. So we're going to have get task, get tasks, update task, create task, and delete task. And we need to require them from the controllers. So we're going to go up one directory and we're going to access controllers and we're going to access tasks. So now we can use these functions. So for the first one, which gets all our tasks, we're going to pass in the get tasks function. The second is create task. The third is get task. The fourth is update task. And the final one is delete task. And now we can save our file. Now, as you can see, our code is much cleaner. So we have our routes in a separate file, our controllers in a separate file, and our index.js in a separate file. Now, to make sure that this refactoring has not broken our application, we're going to head back to Postman one last time and test our different routes. So first, we're going to test the post route. And we're going to give it a name of testing 4. And completed, we can leave out since it has a default value. And we're going to send our request. And if we look at our response, we can see that a new task has been created. Next, we're going to get all our tasks. So we're going to change the action to get and send our request. So we're getting testing 3 and testing 4. Next, we're going to check the route that gets us an individual task. So we're going to copy an ID for testing 3, and we're going to pass it to our path and send the request. So that works. We're getting testing 3. Next, we're going to check the update. So we're going to pass in patch. And we're going to update the name to hello. So if we send our request, we can see that we get the task with the name updated to hello. And finally, we're going to check if the delete works. So we're going to have delete, and we're going to delete this task. So we're going to send the request. And if we look at our response, we see task has been deleted. Now, in the coming videos, we're going to build a front end using React, and we're going to connect it to our server. Thank you for watching this video, and don't forget to like the video and subscribe to our channel for more programming content.